Well, you mentioned, and this is something that I've heard people ask me about the frogs being able to turn into female frogs. And I thought, well, let's just go ahead and take that on right off the bat because a lot of people seem to think that frogs, that's like a normal type of behavior for a male frog to turn into a female frog. Is that normal?
That is not normal, and that does not occur. I'll tell you where that comes from, because I used to get this question a lot. Frogs are what are called gonochoristic. Males are males and females are females. There are fish that are naturally hermaphroditic, and there are species of fish that can change from a male to a female, and vice versa. There are no frogs, no amphibians that are known to do this. But I can tell you where that idea comes from. Jurassic Park.
Oh,
So,
really?
if you read the book or see the movie, they supposedly filled in the dinosaur DNA with frog DNA, and they make a statement in the book and in the movie that frogs naturally change sex, and supposedly that was the premise for why the dinosaurs changed sex and started breeding in Jurassic Park. So that's where most people get that idea from, that it's been spread through the science fiction literature.
Well, that's too bad because I like it when television and movies actually help to educate people with with like real facts and not made up ones
Yeah.
that kind of fits into the movie. Now, you say that it feminizes and it's a hormone disruptor. Now, people hear that, and I'm sure a lot of them it's kind of like in one ear and out the other. They're like, okay, hormone disruptor, but is that really such a bad thing? What does it mean when something is a hormone disruptor? What is it doing inside of our body?
Well, I always point out to people that we make intentional hormone disruptors that can end up in the environment. So, for example, if you're using chemical birth control, that's a synthetic hormone that's designed to manipulate your hormones and to manipulate your physiology, in this case, so that you don't get pregnant. Things like hydrocortisone cream, these creams that are endocrine disruptors that are specifically designed to reduce your immune function. For example, if you have an allergy or if you get a heart or tissue transplant and you need to knock down your immune system. That's an intentional endocrine disruptor. Even to some extent, aspirin and Tylenol is an intentional endocrine disruptor because it's knocking out the hormones that cause you pain. So we've known that we can invent chemicals that are endocrine or hormone disruptors. Or insulin, for example, synthetic insulin, you might consider a pharmaceutical intentional hormone disruptor. Right?
And didn't aspirin come from a tree?
Aspirin's a natural product, comes from the willow. I think
White
it's in
white willow bark, yeah, white willow bark, yeah.
Yeah. The problem is when these chemicals, even if they're intentional, for example, ethinyl estradiol birth control pill can end up in water supplies in the same way that estrogen mimics our estrogen as humans and manipulates our reproductive physiology. It can unintentionally disrupt the reproductive development and function of exposed wildlife, of fish, for example, or anything that goes off and drinks water that's contaminated with ethinyl estradiol. And the problem is compounded by chemicals like atrazine, which aren't designed to be endocrine disruptors, but unintentionally, in addition to atrazine as a weed killer, it kills plants, but it has this other function where it causes this reproductive toxicology. And when you have such widespread use, we're using something like 80 million pounds of atrazine per year in the U.S. alone. DDT was another example that DDT mimics estrogen, among other things, and when people and animals are exposed can lead to increased breast cancer or other types of endocrine disrupting effects. That is what becomes problematic.
Well, and so it actually makes the testosterone drop and estrogen increase in these frogs. Is that what you saw when you were testing them?
Not just in frogs. Atrazine decreases testosterone in fish, amphibians, reptiles, birds, and mammals, including lab rats. And atrazine increases estrogen in fish, reptiles, birds, and mammals, including human cell lines, rats and human cell lines.
Well, we're using this in the United States. What does the rest of the world think about atrazine?
Atrazine in 2000, I believe, was banned by the European Union, and and it's not used in all of Europe. The irony being that the company, Novartis, now Syngenta, is based in Basel, Switzerland. So we're using 80 million pounds of a chemical that's not even allowed in Europe. It's been banned in a few other countries, and if the EPA continues and has any teeth, it'll be banned in the U.S. But the European Union banned atrazine, well over 10 years ago.
And so the company knows from your research what their product does to people and animals, the environment, and yet they're okay with selling it.
Well, there are several things. I have to tread lightly here because the lawyer likes. In fact, I have one of his letters permanent letters hanging up above my desk. I can tell you that the company knew before my research. I think that's why I was hired in the first place. There were conversations around the room when I was working. I was hired by the company, contracted. There were conversations about the adverse effects of atrazine before I even started my research. So they knew. And I was told by key players that they knew this going in. And the company themselves had published papers showing that atrazine disrupted androgen and estrogen and progesterone, the pregnancy hormone, in rats. So they already knew this. And the scary thing, the really unethical thing that strikes me is, again, the company knew that atrazine was bad. But in the same year, in 2000, when they discovered that atrazine induced estrogen production, the company Novartis, in that same year, before they split and became Novartis and Syngenta, started selling a breast cancer treatment that did exactly the opposite, that blocked estrogen production. So, so some people in the company must have known, hey, we're making a pesticide, this weed killer, that turns on estrogen, and we're also selling chemical that turns off estrogen to treat breast cancer. And to give you another idea of some unethical things, I can read to you from their notes, which are now published since a court case was settled. When atrazine was banned in Europe in 2000, shortly after, in 2002, I believe, in their own company notes, they write that this chemical, TBA, terbutylazine, and I'm reading from their handwritten notes, may be a bit more potent than atrazine. So one, they're admitting that atrazine does something. They wrote, TBA may be a bit more potent than atrazine. Lower doses cause same effects. And then they went on to say that it causes testicular cancer and let's see, because I want to read directly because their lawyer doesn't write me a good little note, that it causes testicular cancer and mammary tumors in rats. This is the chemical that they then, in that same year, released in Europe to replace atrazine. So these people are sitting in a room saying, okay, atrazine has these adverse effects. This chemical TBA does the same at lower doses, but let's release it in Europe. And that's in their own writing. So
in layman's terms, the notes that you just read, how would you simplify what that says? I know you wanted to stick with their words. Is there another way to say it?
That they're knowingly releasing a chemical into the environment that they know is associated, that can cause testicular cancer and mammary cancers, and it does the same as atrazine. So it's not like they sat around a table and said, oh, we've discovered now that atrazine has these really negative effects on the environment, on animals and humans. Let's get rid of it. They said, okay, it's been banned now. Let's release a chemical that we know is even worse. How do you, and this goes beyond the science, how do you as a person make that decision at work and then go home to your family and to your kids and go, okay, I've just condemned somebody else's kids and the environment to exposure to this chemical that I know is bad.
And when isn't the baby that's in the womb, isn't that when they're the most susceptible?
I've often argued that a developing human fetus trapped in a contaminated amniotic fluid is no different than one of my tadpoles trapped in a contaminated pond or a contaminated aquarium. Because chemicals like atrazine cross the placenta, and in the same way that my tadpole in a contaminated pond can't get away, the fetus can't get away. And we make and use the same hormones as fish and amphibians do. So in the same way that atrazine depletes testosterone and increases estrogen in fish and amphibians, it does the same thing in mammals, including humans. And we know from rats, there are studies by the EPA that shows that if you feed a rat atrazine when she's pregnant, her sons will be born with the prostate of an old man. Her sons are born with prostate disease. The daughters are born with poor mammary gland development. So we know these effects are occurring across generations. And there's correlational studies showing that atrazine exposure during pregnancy in humans is associated with birth defects like gastroesthesis, where the intestines are born on the where the baby's born with the intestines on the outside of its body, choanal atresia, where the baby will have a hole in its face where the nasal and oral cavity don't close up, and can be born with the males that are exposed in the womb or born with genital malformations that are identical with malformations you see when a baby is depleted of androgen or exposed to excess estrogen.
So it's really kind of doing the math when you take away these hormones that are critical for development. You have to know that there's going to be a side effect of that. And I've had an experience interviewing someone that for 25 years has been studying wildlife in Montana and doing autopsies. Her husband's a ranger, and they have a vulture sanctuary, so he picks up roadkill. And he would bring it home, and I can share that link with you, but the pictures are just very disturbing, where they have extreme malformations in overbites. She said that she found micro penises. She said they used to make fun of the squirrels because they had big ones. She said, and they don't have big ones anymore. And she said that they were born without testes, and even like they were misshapen, pointing different ways. So they can't chew, they can't have sex. It's just, it's very upsetting. And the birds, even with tumors. And so atrazine is like something that's found in water more than any other pesticide. Is that correct?
That is correct. Yes, it's the most commonly detected pesticide in rainwater, groundwater, drinking water, you name it.
How come atrazine is found in water more than any other pesticide?
There are a couple of reasons. One, we use so much of it. It's the second most widely used pesticide, second only to glyphosate or Roundup. And two, it's very highly water soluble. And it's also very persistent, so it doesn't degrade very readily depending on the environmental circumstances. It doesn't very readily degrade. So it can brown. The last time I saw talk in France, it had been banned for a decade, and it was still around in the aquifers, even though they weren't using it there.
And I saw this one really shocking statistic that it was like here that some farmers could actually use levels that were 200 million times higher than we're using in the laboratory. Does that sound right?
I don't have the data in front of me, but I think the number is 240 million times that, and that is the application rate, the range that's recommended for atrazine use can be up to 240 million times what we're using in the laboratory, because we get effects at depending on the effect, we get some effects at 0.1 parts per billion, and the recommended application rate goes up to 240 parts per billion, I believe. So, yeah.
Well, as I read through some of the results that you got from your research, and then you look at some of the behavior and some of the things happening in society, reproductive health, the amount of diseases that we're seeing that have to do with the reproductive system. Then see, what were some of the other things I was thinking? Well, let's just take that for example, where we think that maybe people that are homosexual are coming out more, and we're finding more of the people that way because they feel more comfortable about coming out. But do you think that there could be this feminization of the males, that there could be a link between the use of this atrazine and people's sexual orientation?
That's a complicated question.
Yeah, I kind of thought that was a toughie.
And I'll tell you why. I mean, it's complicated for both scientific reasons, and it's also complicated for both socio-political reasons. The scientific reasons are that across geographies and cultures and time, it's difficult, at least I don't know of the numbers, to show whether or not there's an increase or, as you said, whether or not just more people are more comfortable. And the example I use to express that is I grew up in South Carolina. I've been in California for almost 30 years. And I know I can name for you 10 people, for example, who's undergone transsexual transition, both male to female and female to male. And I know people that range everywhere from some of my daughter's friends, so who went through transitions as teenagers, to some of the parents of my daughter's friends, to some of my coworkers, to graduate students, to undergraduates, to professors who've undergone transgender operations or transitions. And so it ranges. So it's not an age thing. I know people from my kids' age to older than I am, to retired professors. I know nobody in South Carolina. Now, what does that mean? Does that mean that there's greater exposure in California, or does that mean that there's greater acceptance or more people do? So it's really hard to say what the trends really are, and it's really hard to link that. But again, you might argue California is an agricultural state that uses more pesticides than any other state. So you might argue there's a connection, but we just don't have the science for me to comfortably and responsibly say that. Now, that being said, I have a graduate student, and we have been studying how atrazine affects behavior. And we have shown, we're about to submit a paper for publication now, that male exposed frogs that are exposed developmentally have a higher tendency to display what we're calling homosexual behavior. And so if you asked me, do I think it's scientifically plausible that exposure to a chemical or exposure to anything that induces a hormone imbalance would predispose you to gender transitions or to homosexual behavior? Absolutely. I think we know that hormones wire the brain, that your sexual identity is not just, it's not genetic. Genes may be involved, but we know that hormone exposure is incredibly important for whether or not you identify and whether or not you behave, quote unquote, as male or female. So would a chemical that interferes with that balance potentially have that effect? I don't think any scientist is not paid by the chemical industry. I don't think they disagree. Do we have the evidence to show that in humans now? I would say no. Is it possible? Is it probable? I would say yes, but we don't have the evidence that would make me comfortable enough in saying that.
Even though some of your research where you took the atrazine exposed frogs and put them in with a control frog that had not been exposed to atrazine, that the atrazine exposed frogs didn't seem too interested in the females, and normally they would never get the girl.
That's correct. So it's very clear that atrazine eliminates male behavior. And even if they're alone with the females, they don't display male reproductive behavior. They have a very low success, even if there's no competition. And in our unpublished data, many of those males actually show a tendency to behave as a female, to allow themselves and maybe even to solicit matings from other males. But that's under controlled conditions where we know exactly what they were exposed to, and the behavior is very simple. Human behavior is much more complicated, and there's a much more complicated social context to whether or not you display the behavior, or even if you have that tendency, whether or not you act on it. You know what I mean? So whereas frogs don't, there's no such thing as frogs on the down low.
Yeah, I'm picturing them, Hey man, did you check out that guy over that new frog that just came? So, an easier question. I saved this one for the second one because I thought it was easier because it's probably more something that you could actually measure, and that's fertility. Because it seems to me as a dietitian that we didn't have all these fertility clinics and people that were having trouble having babies the way we have today. Are you seeing actual numbers related to fertility where you're seeing that there are changes, where there are more people that are infertile? Because that's a really expensive thing. When you have to go to fertility clinic, you're talking like 50 grand or something to get pregnant.
Well, and that's one that I can speak to more directly because we do have the data. So there's data in Northern Europe. A guy named Schackenbach has produced the data showing that sperm count has steadily gone down every generation. So we have hard data that human fertility, that sperm count has decreased over 50 plus years. And we also have correlative data showing, for example, Shauna Swan did some studies showing that men who have atrazine in their urine have lower sperm counts and lower fertility and more difficulties with getting their wives pregnant in a study that she did in Columbia, Missouri. So we have direct evidence, and we have rat studies that show that if you
I can't hear you. I couldn't hear that last thing you said. If you could repeat it.
Oh, and we have experimental data showing that if you give a rat atrazine, sperm count declines precipitously in response to atrazine. That's been produced in the laboratory. And we have similar data in fish, amphibians, birds, and reptiles showing that atrazine causes sperm to decline. So that I feel confident in saying that atrazine very seriously adversely affects male reproductive development because it's been shown experimentally in fish, amphibians, and reptiles, and birds, and lab rats, and it's correlated with the decline in sperm count in humans. So that I feel confident that atrazine is maybe not the only chemical, and maybe not the only factor, but atrazine appears to be playing a very strong role in the loss in male fertility.
Well, and I know it's kind of a weird thing to talk about, but I am a dietitian, so I'm okay with it. But the micropenis issue, and I bring that up because I know that the lady that studied the wildlife, not only did she see these micropenises in the wildlife, but she said that it was happening to human babies too, and I've heard other stories. And I don't know if that was like kind of a normal thing, but to me, a male, that would be kind of a devastating kind of thing to happen. And even as a parent, and plus I'm hoping that if people get scared of it, maybe they would like try a little bit harder, because if it's a real thing, they should know. And people don't want to talk about it because it's kind of embarrassing. But if it's a real thing, I want people to know about it.
Yeah. Well, that's another one that I feel much more confident in speaking about. Because atrazine does, and I'm looking for the study now so I can tell you the authors, but atrazine does decrease testosterone, and as I'm sure you know, testosterone is necessary for male genital development. Sorry, let me just pull this.
No, go ahead, and if you want to look it up, I can cut it out. So
yeah, so atrazine decreases androgens and increases estrogens, and both of those things we know will affect male genital development. Too little androgen or too much estrogen. Again, we have experimental evidence where atrazine in fish and in frogs and in reptiles and in mammals decreases male development. And in fact, there's a study in reptiles and alligators and caimans showing that they come out with really small penises when micropenis, when these reptiles are exposed to atrazine. And there's a study that was done at the Baylor College of Medicine. The first author is Agopin, I'm not sure how to pronounce it, but this study showed that atrazine was correlated with micropenis, hypospadias, where the urethra doesn't end all the way through the penis, and cryptorchidism, where the testicles don't descend in the scrotum. They showed that atrazine was correlated with these types of male genital malformations. I'll just, their conclusion in their study was our results provide further evidence of a suspected teratogenic role of atrazine. They showed specifically that there were consistent associations between medium-low and or medium levels of maternal residential atrazine exposure and every male genital malformation category evaluated. So there's hard data to show that atrazine is causing this problem, and there's a consistent mechanism that's reproducible in experimental laboratory studies.
Why does it affect males more than females?
I think that's mostly because, I think there are two reasons for that. One is I think it's mostly because of the mechanism that you decrease androgens and you increase estrogens, and females already have higher levels of estrogen. And so in our frogs, I had an undergraduate student, Faye Pond, who said, how come we never study the females? And I said, well, because females already have estrogen. And so it's hard to show that a little bit more estrogen is having an adverse effect. So that's part of the reason, is the mechanism. Alternatively, however, there are effects on females, like, for example, mammary tumors are increased with atrazine in rats, and there's at least one study that associates mammary tumors with atrazine exposure in human females, because mammary tumors or breast cancer is estrogen dependent. And also the birth defects and the problems with carrying the baby to term. Atrazine induces abortions, for example. That's been shown by the EPA.
Wow.
EPA.
That's heavy duty. Now, one of the results that you got from your test, I think it was from your testing, was change in the larynx tissue. Now, I'm wondering about, like, first of all, like, you hear commercials, low T, that kind of thing. But I don't know if they I don't think they really go into, okay, if you have low T, what are the side effects of that? And then I was also, in the same question, I was wondering about the larynx tissue, because in males, in the teen years is when your voice changes. And so I'm wondering if maybe some of these males that are exposed never go through that voice change. So like what happens when you have low testosterone in your body, even when you're at different stages of growth, but then also how is that impacting the voice change?
That's correct. So we have seen morphologically the voice box of these animals, which looks, if you're exposed to atrazine, looks more like a female's, and that is maintained for life. And I have a student, Mind Win, who's been interested in studying, because frogs mate, they attract each other by their voice. The males sing.
Oh, I didn't know that.
Yeah, that's why the males sing. So the female. So if your voice box is affected and you don't sing properly, then it'll have a big impact on whether or not you can attract a female and whether or not you can successfully reproduce. And you're absolutely right. In humans, just like in frogs, androgens like testosterone are important. That's why back in the early days, the choir boys, they would castrate them to remove the testosterone so their voice would not change. Effectively, that's what we've done to these frogs by treating them with atrazine, is we've removed the testosterone so they don't develop a proper male singing voice, a deep voice. And you might expect that similar things would happen to humans and other animals if you are deprived of testosterone that's so important during those critical times of development. I don't know of any data that have examined that, but like with the other behavioral question we had, it's certainly plausible that might happen.
Well, I've read chemical castration.
Yeah.
And when I think of that, I think of what they used to do to sex offenders that were caught and sent to prison, and they would give them a choice, I guess, before they could get paroled. If they would agree to be chemically castrated. How does that compare to what atrazine does?
I would think that many of the chemicals that they use, most of which I think are reversible for that type of procedure, are more characterized and more potent at doing that than atrazine. And that the chemicals that I know of are either ones that block testosterone from acting or that act on the brain and pituitary to stop the hormone signal to the testes. So it's a different mechanism and probably has a longer half-life in the individual.
So when you say the babies are born with old man testes, what does that mean?
Oh, I said old man's prostate. So,
prostate. Okay.
Yeah. So as you age, you are more prone to prostate disease, enlarged prostate, or prostate cancer. So the prostate, whatever reason, starts to enlarge and can even cause blockage of urination and things like that in older men. So in rats, when males are exposed in the womb, the male pups are born with the prostate that looks like one of an old man. They're enlarged and experience prostate disease that they normally shouldn't experience for the equivalent of 60 human years. Right? Make some numbers clear because somebody is always watching. So the package of atrazine recommends application at 2.9 to 29 million parts per billion.
Okay.
We get effects at 0.1 parts per billion, which means that the application rate can be 290 million times higher than we're using in the laboratory. So that's the statement I did. I didn't have the numbers in my head, but I just looked it up to make sure. In terms of what people can do, I think one, in their own personal lives, do the best you can to avoid using synthetic chemicals and pesticides in the home in your personal use. Supporting local organic farms, very important, as much as you can. I think there's a value in growing whatever you can, even if it's a couple of pots of tomatoes on your porch, but just getting a better understanding of where your food comes from and what it means to actually grow food, I think is incredibly important to understand the people that are actually growing your food. And I think also doing your best to stay informed and inform others and taking advantage of, for what it's worth, the EPA, for example, has comment periods where anybody can write in and give their opinion. So making yourself informed and knowing about those decisions, voting for local and politicians that reflect these ideals, I think is incredibly important. I don't know what else I can say. Just
No, those are great. That was an incredible list. I'm actually going to type all that up. I'm going to put it in a graphic and says this is what Dr. Hayes says you should do, because that was an excellent list of action steps for people to take and to protect their family, because that's, people protect their family and don't want their child running out into the street, that kind of a thing, but they're not realizing that choice they're making at the supermarket could have just as big an impact, maybe not today, but later on. And when I fed my children, I was thinking, I want to protect you now from getting heart disease when you're 40 years old, or getting cancer when you're 40 years old. I want to establish habits as a child that will go into adulthood with you, so that you will have less of a chance to get that. And you actually have an opportunity when you're a parent to do that for your child as an adult. Thanks, Dr. Hayes. Have a nice summer.
All right, thank you.
Bye-bye.